Hello everyone. In this lesson, we will be talking and learning about cylinders and how to find the volume and surface area. Again, a quick reminder, a volume is the space inside three-dimensional shape, and the surface area is the space on the outside of three-dimensional shape. Okay, so cylinder, what is a cylinder? If I were to unfold a cylinder, it will have a rectangle that I can fold into this the cylinder looking shape or cylinder shape. And then it also has two circles that this rectangle will wrap around to create that cylinder that we're talking about. So the first part of our notes, we will be working with the volume. So we're going to find volume of a cylinder, and our cylinder has a height of 3 inches. So let's write that down. Height is 3 inches, and the radius is 2 inches. Okay, so again, let me unfold my cylinder really quick and we can label these parts one more time. So the height of a cylinder, so this is how tall the cylinder is. It's h, which is 3 in our case. And the radius they're talking about is referring to the top and the bottom of a cylinder, or in other words, a circle. So just a quick step aside. If I draw a line from one side of a circle to another side of a circle that passes through the center, this line is called a diameter, right? Now, if I take the half of that line, the half of that diameter is called a radius. So this is exactly what we need for our volume and surface area formulas, this part, radius. Okay, half of a diameter. So to find the volume of a cylinder, we would have to multiply pi. Okay, pi is approximately 3.4. That's the number we're going to use for it. So we're going to multiply pi times the radius, this little green part of the circle. And the radius is raised to the second power. Okay. By the way, this is how we find the area of a circle. Okay. And now we're going to multiply that area of a circle by height of our cylinder, and this will give us volume. Pretty simple. Looks complicated, but it's nothing scary. So volume, I'm gonna leave pi as pi for now, and I'm going to substitute radius and height into my formula. So the radius is 2, and I know that 2 is raised to the second power, and the height is 3. So this is a very important moment. You have to follow order of operations. If you don't follow order operations, you will not get a right answer. So right now, looking at my numbers, I have times, and I have an exponent. Okay, JM does, so PM does. What do I do first, multiplication or exponent? I have to do exponent first. So 2 to the second power becomes 4. I'm going to bring the rest of my numbers down. Okay, now I can multiply, right? So now it's okay at this point to replace our pi with 3.14. Multiply by 4, multiply by 3. Or you could have multiplied 4 times 3 first and then replace pi with 3.14. All right, in either case, 3.14 times 4 times 3 is 37.68. So it's been measured in inches, and we're finding volume. Volume is always cubed to the third power, so our answer is 37.68 cubic inches. Ta-da! All right, next question, and the next part of our notes will be about surface area. So surface area, write that in, surface area, you can just say SA. Surface area is the total area of all faces of three-dimensional figure, just like with rectangle. To find surface area, we have to find area of all 6 faces and kind of add them together. So doing the same thing for the cylinder. We're going to find area of one circle, area of another circle, okay, and then the area of this rectangular part, and add it all together, okay. While the circles are the same same size, so we would just have to find the area of one circle and then double it. Okay, so how many faces are there in a cylinder? Well, I have one circle, I have a second circle, and I have a body, right? It's three. So it has three faces. Okay, and what shapes make a cylinder? Well, we just said it is two circles and a rectangle. Okay, so, okay, there we go. So that's about surface area. Net, again, a net is a representation, a two-dimensional representation of three-dimensional shape. So same exact thing. So this numbers are kind of hard to see, but so the cylinder has been unfolded into this net, and the radius is 2. That's where we find radius, always in a circle. And the height, I'm going to go with 6. The height is 6. And that's where you locate information, but the height is also going to be right here. Height is 6. All right, so here is a surface area problem we need to work out. Which formula would be used to calculate the surface area of a cylinder? So first of all, here's the formula. 2 times pi times r times height. This is how we would use the find the rectangular portion of a cylinder. Plus, we are going to double the area of a circle. Pi times radius squared is area of a circle. We have two circles, that's why we're doubling it. So anyhow, the height of our cylinder is 3 inches and the radius is 2 inches. Same exact measurements, we're just looking for surface area now. So the idea is exact same as with volume. So we have 2, we have times pi, then we need to replace radius and the height with the numbers, plus 2 times pi times a radius raised to the second power. Okay, so 2 times pi times r. R is 2, so I'm going to put 2 in my first set of parentheses, times h. H is 3, so here we go. And then r in the second part is 2 inches, so here we go. So you sort of kind of also have to work this out in chunks, if you will. That'll make things easier. Okay, and you have to follow order of operations. So the first thing I'm gonna do, since I like doing things step by step, I'm going to just rewrite what I have in my first set, but then I'm going to simplify the exponent. Now it becomes 4. Okay, so now it's okay to replace pi with 3.14. Okay, plus 2 times 3.14 times 4. Again, following order of operations. I have to multiply first. I have to multiply first, and only then I can add those numbers together. So 2 times 3.14 times 2 times 3 is 37.68. The second set of multiplication is 2 times 3.14 times 4 gives us 25.12. So this number represents the area of the rectangular part, and this number represents the area of both circles. So if you add it together, you will have the total surface area of this cylinder. And it is square inches since it's an area. Okay. All right, moving on. Again, the practical problems will not always be clear and straightforward to what they want you to find, but you have to look for words that would indicate inside the shape for volume. Okay, so the words can be water, the words can be fill, the words can be how much can it hold inside. I don't know. So those things. And the words that indicate, and oh, excuse me. And the words that indicate outside of the shape, okay, will refer to surface area. So words like cover, paint, wrap, um, how much does it take to make? So how much aluminum does it take to make a can? All right, so the can is not gonna be solid inside. It's gonna have space inside, right? So the material are gonna go outside of our can that we're talking about. So that would all be indicators of surface area. So here is our first example on the word kind of problem scenarios. Sandra has a small cylindrical water cooler that she would like to fill with lemonade. If her bottle is 52 centimeters tall and has a diameter of 20 centimeters, how much lemonade can this cooler hold? So is that a surface area or volume? My first question. Okay, so just go back through the problem and see what kind of keywords we can identify. So she has a small water cooler that she would like to fill with lemonade. Okay, there's no way she's gonna put the lemonade on the outside of that cooler, right? It's all gonna go inside. So that tells me that it's a volume kind of question. So the bottle dimensions are 52 centimeters tall, and then the diameter is 20 centimeters. Okay, so let's begin with writing a formula down and see what kind of information we have and what's missing. So volume would be pi times radius squared, which will give me area of a circle, times height will give me the volume. All right, so the formula calls for bar radius, but I don't have a radius. But I know that in a circle, diameter is the line that goes all the way from one side to another through the center. And I know that the radius is the line that goes only halfway, okay? So that tells me that radius is the half of a diameter. So if I know that diameter is 20, so this whole line is 20, what would be the half of it? And the half of it will be 10. 20 divided by 2 is 10 centimeters. All right, now that I have all of my numbers, I can start replacing. Leaving pi as pi for now, radius to the second power, and the height. So the radius is 10. The height is 52. Okay, order of operations, I've got to do my exponent first. 10 to the second power is 100. So let me rewrite it right here. Pi times 100 times 52. Now it's okay to replace your pi with 3.14. Okay, and multiply numbers together. You could multiply them straight across. It would not make a difference. Okay, and 3.14 times 100 times 52 is 16,328. Volume is cubed, so cubic centimeters. Here's your answer. This is how much lemonade it can hold. Sounds like a big number, right? All right, next question. A cosmetic company that makes small cylindrical bars of soap wraps the bars in plastic prior to shipping. The soap has a radius of 5 centimeters and the height of 6. Is this the surface area or volume? That's the first question. So let's go back through the question. Cosmetic company makes small bars of soap and it wraps them in plastic. So what they do, they wrap it on the outside. And the outside means it is a surface area kind of question. Let's see what kind of dimensions they give us. So the height is 6 centimeters and the radius is 5 centimeters. Let's retrieve the formula, and the formula is surface area is 2 pi r h. So 2 times pi times radius times height plus 2 times pi times radius raised to the second power. Okay, let's replace our numbers. 2 pi r h plus 2 pi r squared. R is 5. Okay, we already have radius. We don't have to find it like in the previous problem. Height is 6. 2 pi r. R is 5. Again, we need to do order of operations, follow order of operations, and simplify our exponent first. I'm going to erase this part and just write my steps on the side. So 2 times pi times 5 times 6, 2 times pi times 25. Okay. Now I need to multiply this parts and then add them together. So I'm not gonna rewrite pi was 3.14, but this is what I'm gonna put in my calculator. So 2 times 3.14 times 5 times 6 is 188.4. And for the second part, 2 times 3.14 times 25 is 157. Now I can add these two areas together, okay? 345.4 centimeters. That was surface area, so square centimeters, okay? There we go. So the reason I'm keeping pi inside in the problem for so long is because some questions on the test might ask you which of this formula, so which of the setups can be used to find surface area or to find volume, and what they're going to give you is something that looks like this, and they're going to try to confuse you with putting wrong numbers in but keeping pi inside. So you need to be able to identify, be able to do this step and see that pi is part of the formula. So like I could have replaced pi right here, right in the beginning, but I'm keeping it in the problem for a reason, and that's the reason. Okay, so you guys are gonna find the volume and surface area of this cylinder below. So for your volume, this is where you're recording your answers and steps, and this is your surface area spot. Let me know if you have any questions, and continue working on this. Question 3.